Okay, so in this problem we're looking for numbers that are divisible by 4. If we know the divisibility rule for 4, we know that all we have to do is find numbers that the last two digits are divisible by 4. However, there are a lot of possibilities when you're talking about 12 different digits that satisfy this condition. Unfortunately, there is no clever way to go about it except to list out each one of the possibilities and then calculate each one separately. Luckily, some of them fall into similar categories, which will allow us to limit our calculations a little bit. So we just start with 12 as that's our lowest multiple of 4 that we can create with two numbers. That leaves us with 10 possible numbers left to be the first 10 numbers or digits of this number. So we're going to arrange those 10 numbers. Well, we can use what we call the letter arrangement formula, which says 10 factorial divided by whatever repeats we have. Well, 1 is one of the repeats, but since we've already used one of the ones, there's only one left, so there's no repeat. And then there are 3 4s and 3 8s. And so what we recognize is this is a very specific case, and that is when you have a 1 but not a 4 or an 8. And so we'll pay attention to see if we have any more of those and then fit them in the same category. So the next one would be 16. Well, 16, as you can see, actually fits in the exact same category because it is a 1 without a 4 or an 8. So that gets us, we'll just put 16 in this category because we know it's going to be the same number of ways that you can have a number end in 16. We'll move on to the 2's. The first one of the 2's would be 24. When we calculate 24, that does include a 4. And so that leaves us with 10 numbers to form the first two. Now we have to count the 1, so we do 2 factorial. Take away one of the 4s, so there's just 2 left, so 2 factorial. And then the 3 8s gives us 3 factorial. So this is a new example of a possible case, and so we'll look for ones that are like that one. We do 2 8. Well, this is exactly like that one because instead of being a 4, it's an 8, but you're going to have the exact same thing. So let's put 28 in that category. Then we look in the 30s. We have none in the 30s, so then we go to the 40s. The first one in the 40s would be 44. Now this is going to be a new category because we have gotten rid of 2 4s, and so we're left with 2 1s for 2 factorial and 3 8s for 3 factorial. So that was a new case for us. 48 is also a new case because we've taken one of the 4s away and one of the 8s away, and so it's going to be 10 factorial over 2 factorial, 2 factorial, 2 factorial. You got 2 1s, 2 4s, and 2 8s left. Look in the 50s. 52 is another new case because it doesn't include any of the repeated numbers, and so it's just going to be 2 divided by 2 factorial, 3 factorial, 3 factorial. And it actually turns out that these are all the possible cases, and so as we go through, we're going to fit each of the numbers into one of these cases. So the next would be 56. 56 is just like 52, so it goes into this case. It doesn't include a 1, a 4, or an 8. We look in the 60s. 64 includes one of the 4s, but not an 8 or not more than one 4. And so it's going to fall into the 24 category and 28 category. 68 will fall in there as well. You look at the 70s, you got 72. That doesn't use any of the repeats, so it falls into this last category here. So does 76. And then we look in the 80s. 84 falls in the category of taking 1 from both of them, which would be obviously 48 because it uses the same 2 digits. And then finally, 88 would fall in the same category as 44, and so we put the 44 here. So to calculate this, you do this, and there's 2 of them, 12 and 16, and multiply by 2. You do this, multiply by 4. Do this one, multiply by 2. It's supposed to be 88. Do this one, multiply by 2 to get there. And then finally on this one, you're going to multiply by 4. And those are all the possibilities. And it turns out that your answer is actually 252,520,000 ways. It's just a matter of going through and doing each one of those calculations.